Good morning, class. This is Mr. Walker here, coming to you with our notes for today. We are talking about rotations, people. We're almost at the end of all the transformations. This is our second to last one. So, let's do a quick review again, like we've done with the last couple times. First off, a transformation, remember, is a function that maps a figure onto a new figure. Now, we've done with two of them so far. We've done a translation, which is a sliding our shape from one place to another. We've done a reflection, which flips our shape over a line. Now we're dealing with a rotation. Now there's a couple rotations that we could talk about, but for the sake of time, we are dealing with around the origin of our coordinate plane. So a rotation is a turn. Now remember, these things are going to be turning around a certain point. This point that we're going to be talking about is the origin. So imagine this was right where the x and y axes cross, and we are rotating the shape around it. So let's go through. Let's get a couple of things together. Let's go through. Let's get to it. Let's get into it now. All right, let's get into it. Rotation about the origin. So, rigid motion, as we remember, is a transformation that turns a figure about a fixed point, and that is called our center of rotation. Now, we've done with rigid transformations before, that just means that the shape still stays the same as we turn it around, or flip it around, or slide it around. But this time, we are going to be doing a certain type of turn. So, let's go through and explain this turn a little more. So, on a coordinate plane, we're going to assume our center of rotation, the point that we're rotating around, is the origin, unless told otherwise. Now, we're not going to deal with the other y's because honestly, that involves a little more supplies than we currently have and time that we don't necessarily have to go over this. Okay? Now, rotations can be clockwise or counterclockwise. So, make sure that you understand how to read a clock. We're obviously going to go over it because I know not everybody has a clock. Now, we are going to assume a positive angle of rotation turns the figure counterclockwise unless told otherwise. Now, what is clockwise and counterclockwise? Clockwise is us going around the clock from the right side. So, going from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, back to 12. So, going around the shape towards the right. Counterclockwise is the opposite direction. So, going in the left direction. Okay? So, going from 12 all the way back around to 1. Now, when we're dealing with this on the coordinate plane, we have our original shape right here where the right angle's at. This is at 0 degrees. Now these couple of degrees that we have around here, these are the different types of degrees that we're going to be dealing with. We're going to go through and map these out in just a second. But we have 0 here, right on the positive side of the x-axis. We have 90 on the positive side of the y-axis, 180 on the negative side of the x-axis, and 270 on the negative side of the y-axis. And then that brings us full circle to 360 degrees, lining up where 0 degrees is at. So, let's explain a couple of the rotations that we're going to be dealing with. So, we got three basic ones that we're going to do: 90, 180, and 270. Please make sure that you follow these rules as to not, deal with confusion, okay? So, if we're making a 90-degree rotation counterclockwise, we have our x and y, and they will flip positions, and we will be turning our y into the opposite sign. Next, if we have 180 degrees of a rotation, our x and y change to the opposite signs for both. Now, the position of both of these do not change like how the previous one did. The x and the y stay in the same place. The only thing that changes is our sign. Then if we're dealing with 270 degrees of counterclockwise, we have Our y and x switching just like how it was with 90. The only difference is instead of y changing signs, the x changes signs. Now, you might be wondering why do all these say counterclockwise on here? When we deal with our coordinate plane, just as a reminder, our four quadrants are all moving around counterclockwise. Okay? For the most part, you won't have to really guess whether or not we're talking about clockwise or counterclockwise. It will be indicated to you. Okay? So, let's get some rotations around. So, here's our shape over here. We got QRST. We're going to have to look at each of these points here and rotate them 90 degrees. So, 90 degrees, our rotation changes the X and Y's position and takes the Y and changes its sign. So, let's look at our points. First, we got Q, and that's at -2 and 2. Now, if we follow this rule that we have up here, now let's actually highlight this just so we don't, have to keep pointing up there. If we're following this rule correctly, then that means that our -2 for our x will switch to where the +2 is with the y, and then we'll change the sign for our y. So, x switches over to -2, y switches over to the front of it and becomes negative as well. All right, let's check our next one. Now, here's our, well, actually, before we check our next one, our original point Q was right up here. Our new Q, Q prime, is down here, okay? Now, we're rotating around, so a lot of these things here will be switched as we come over into this general direction, okay? Let's look at our next ones. We got R at 7, 4. That changes into -4, 7. See, the Y switched just like how our Y did here and became negative. And the 7 was already positive, it'll stay positive. So, R prime is at -4, 7. Let's look at R. All right, start to notice a couple things. Here's Q prime and R prime. Here's the original Q and R. See how these two form this line that we have here? If we continue, those lines that we had on the original shape will still come through in our new shape. Okay? So, we went from Q to R. We're going to go from R to S with that next one. So, let's take a look at it. Here's our original S. Our S is going to have to follow the same distance that we had here. See how this R is down here, and this is 4 units down and 2 units to the right of S? This same thing should be happening over here. So it should be somewhere around this general area. Let's take a look. We got S at 5, 8. We have to switch the positions of these. So S will have an 8 in the front, 5 in the back, and 8 will become negative. So, see, general location just like how we had before with the original S. So, we're going from S now to T. So, S to T, you notice that both of these are on the same line, right? And they're both not having a diagonal between them. It's just us moving 1, 2, 3 to the left. In this case, we're going to go 1, 2, 3 down, hopefully. Let's check. Here's our original point for T, 2, 8. When we rotate it around, 8 was going to switch where the 2's at, and the 8 will become negative. So, here's our T prime. Now notice, all of these shapes here have the same relationship to what was originally there, okay? Now, obviously, my little line that I made here was a little rougher because I'm not using a ruler, but I could still see that this relationship here is the same thing as the relationship I had here. It's just turned around. So, as we go around, if we're making a 90-degree turn, it takes it from one quadrant to the next quadrant, okay? So, Seeing as this shape was originally in quadrant 1, when I rotate it around 90 degrees, it moves over to quadrant 2. Now, if you actually rotate it around again, this goes from being a 90-degree rotation to a 180-degree rotation. And that would bring you down here to quadrant 3. Now remember, all the relationships that the original shape had to the new shape will still remain the same. So see how S and T were on the same line? S prime and T prime, same place. Now, if you rotate it around the next rotation, 270 would actually bring you around to quadrant 4. And then if you brought it a whole 360 degrees around, that would bring you back to the original shape. So again, this stuff goes from our top right to top left, down to the bottom left to the bottom right, going all around clockwise. Takes a little bit to get used to, but trust me, you'll have some time to practice with it. All right, let's get into some examples. People, let's take a look at how many we got. All right, people, we got 6 examples. Let's get into the first 3. All right. First off, we are rotating the figure around 180 degrees. So let's first remember what our rotation is for 180 degrees, and let's get into it. So 180 degrees, if you remember from our notes, says that our x value and our y value stay in the same place, but the x will become negative and the y will become negative. Let's actually just mark that. So x and y stay in the same place, but their signs will change. All right, so let's note our original points here for this example, and let's see where it's going to move. All right, so A here is at 2, -2. So this is 2, -2. B here is at, this is 2, this is 1, 2, 3, 4, 5, 6, 7. Let's just make sure. 2, 4, 6, 8. Oh, no, sorry, 9. So this B is at 9, -2. And then C, that's coming down to -5. So this is 2, -5. So in our transformation, each of these will rotate around 180 degrees. So this means that this is going to be going up to the first quadrant and then rotating again to the second quadrant. Let's see what our new points are for each of these. All right, our original A is 2, -2. When we switch it around, we have to make sure that our x changes signs and our y changes signs. So instead of 2, -2, we got over here at -2, 2. I'll mark this as A prime just to remember that. Here's A prime. All right, we got B at 9, -2, which means we're going to switch the signs around. This will go to -9 and +2. So here's B. Then C goes around. We still have 2 and 5, but now the 2 will become negative, the 5 will become positive. So that should be where C prime is. Let's see if I'm right. And yes, I am. So again, same places where this stuff was before, just look relatively the same thing as it was, but after, okay? It's exactly like you just turn your paper around and then you were able to go through and see that it was over there. Okay. Now, as you go around, remember, these rotations that we have are going to tell you where to go. So if I was rotating it around 180 degrees, see how I've made those arrows to where I went up to the first quadrant, to the second quadrant? This is just telling me how many times I'm turning. Now for our next one, we're rotating it around 270 degrees. So here's where it is originally. If I make it one turn, this is a 90-degree turn right here. Now if I rotate it around again, this is 180. And then if I make it one more turn, that brings us over here to 270. So we are turning around all the way to here. So this general area in the first quadrant, let me go through and highlight that. This is where we should end up in. This general yellow vicinity, that should show up right about now. All right, so that's our change right there. We want to make sure that we also got what the rule is. So let's review our previous rule. When we rotate this around, our x and y will switch around, and the x will become the opposite sign. So let's get into this one. So let's write this down. Oops, sorry. Erasing. All right, so x and y switch around to where y is positive and in the front, and x is negative and in the back. All right, so things to notice, we got L over here on the y-axis. This is at 0 and positive 3. If we were to switch this around, then that would bring us to 3 and 0, because you can't turn 0 into a negative. So should bring you right here to this red dot I'm making. Now K over here, this is at negative 8 and 1. So this is negative 8 and 1. So when I rotate this around, I switch around the x and y. So our y, which is 1, comes up in front. Our x, negative 8, comes in the back. And then we change negative 8 to a positive 8. So this will give us 1 and 8, which is right over here. And then finally, this next one for J is just 3, no, actually 4. 1, 2, 3, 4. So this is 4 spaces up. So this is negative 8, 5, which should mean that this should be right around here. All right, let's see if I was wrong or if I goofed up, folks. Doom, doom, doom. All right, there we go. So, things to remember. Stuff that's on the line originally, like on one of our axes, this is going to end up being on a different axis, but still an axis nonetheless. And our relationships that we had for our sides will still maintain it. See how J and K are still on the same line as they were originally? That relationship will maintain it. See how both of these go towards L on the right? These are going to both go towards L, but now it's on the bottom, okay? All right. Now, we got another rotation here. We got X and Y are being rotated 270 degrees, which means that Y is popping up front and X is sliding to the back and turning negative. So, here's our original shape here. We're going to be making 2 rotations. Stuff's going to be moving this way, down this way, and down this way. So, occasionally, your shapes are going to overlap, being that this shape is kind of a big one. So, let's know what's going to change. All right, we got A over here. A is at negative 3, positive 3. So this is negative 3, 3. Actually, I'll mark this over here. Make that a little easier to see. So A is at negative 3, 3. If I rotate this around with this rule, then that makes A turn into 3 and 3. So this is our A prime. Now we got B. Let's see where B's at. B is down here in the fourth quadrant. This is at 1, 2, 4, 6, 8. So this is at 8 for its x value, and going down 1, 2, 3, 4, 5, 6. So this is negative 6. So we got 8 and negative 6. Our y value and our x value are going to flip over, and our x value turns its sign into the opposite sign. So this will be negative 6, negative 8 for our B prime. All right, now for C. C is over here up top. This is at 1, 2, 3, 4. This is 4. Yeah, okay. So C is at 4, and it's coming up. So we got 1, 2, 3, 4, 5, 6. So we got 4, 6. The 6 comes up front. The 4 goes in the back, and it changes its sign on us. So C prime is 6 and negative 4. Let's see if that all makes sense for what we got. Let's check it out. All right, let's check. So A prime over here is at 3, 3, like I said. B prime is over here at negative 6, negative 8. And C prime is at 6, negative 4. So you can follow along with the rotation so that you're able to go through and deal with that. Okay? All right, let's get to our next set of practice, people. All right, this time we are describing the rotation that is happening here. So when you describe the rotation, it's best for you to take a look at a point at a time so that you can go through and judge what happened. So let's look at 2 points. I'm going to pick D, okay? So let's go through. Let's go restart. All right, so first one we got here, we're going to be looking at D to D prime. So let's look at D. Let's look at D prime. All right, so D originally is at negative 1 and negative 3. Yep, negative 3. So we got negative 1, negative 3. D prime now is at positive 3 and negative 1. So what did we see happen? The x and y both changed positions. The x came where the y is, the y came where the x is, and then the y changed from being negative to positive. There's only one rule that shows us doing this, and this is a rule for the 90-degree rotation. Now, if it helps, you can also turn the x and y values that you have for your points into just x and y. Keep the signs and then see what changes. Okay? So that's what we got right here for the first one. Next one, we're going to also take a look at one point in particular and then observe what changed. So let's look at M to M prime and see what occurred in our change. So M is originally at, I believe this is 1, 2, yeah. This is at negative 2, 1. M prime now is at positive 2, negative 1. So positive 2, negative 1, and 2, 1, they both got the same x values and y values for the numbers, but the signs changed. Negative 2 turned to positive, and 1 turned to negative 1. There's only one rule that works for this, and that means that this one has to be a rotation of 180. Okay? All right. You've seen a couple strategies for this, so I want you to make sure that you use that for the last one, okay? I want to at least give you something that you got to do. So, look at f and f prime, make the observations that you need to, and then you should be good to go for this. Now,